Hello everyone, in this lesson we will be doing an overview of intermolecular forces including hydrogen bonding, which you know about, but also molecule ion attraction and dispersion forces, which you don't. Copy down these particular do now questions in a separate page for classwork and include the aim, what are dispersion forces? So in general, intermolecular forces are just forces of attraction between molecules. And of all the intermolecular forces, hydrogen bonding is by far the strongest. And it's the result of the attraction between the hydrogen of one molecule and the more electronegative element of a neighboring molecule. And in New York State, this more electronegative element does need to be either nitrogen, oxygen, or fluorine. A good diagram to draw if you're ever asked to represent hydrogen bonding is to use water. And you just need to line it up so that the hydrogens of one are pointing towards the oxygen of another molecule. So causes and effects of intermolecular forces. They are caused by unequal distributions of electrons. But their effects are probably more important. When two particles would normally move away from one another, what would hold them back would be attractions, which we could generalize to intermolecular forces. And if you have high levels of intermolecular force, it's going to be much more difficult to break them, to break those bonds, and it'll be more difficult to boil them because the particles don't want to separate. Therefore, you will have high melting and boiling points. Hydrogen bonding exists between the hydrogen of one molecule and the nitrogen, oxygen, or fluorine of a neighboring molecule, which means that some substances that would experience hydrogen bonding are really just water, ammonia, and hydrofluoric acids. The reason why they have hydrogen bonding is because the hydrogen end is going to be slightly positive, whereas the nitrogen, oxygen, or fluorine end will be, of course, slightly negative. And physically speaking, the bond between the hydrogen of one molecule and the nitrogen, oxygen, or fluorine of another is not really a bond at all. It's just an electrostatic attraction. So molecule ion attraction is a new one for you guys. But in this video, or this GIF won't play for you, but I will show it to you in class. You just need to remind me. But what you see down here is some water molecules. Those are the guys that kind of look like little spaceships flying around. And you also see a crystal structure of negative and positive ions. And what's going to happen is that the negative ion, or the negative part of a water molecule, or the oxygen atom, it's going to line up with a positive ion. And the hydrogen part of a water molecule, I guess, these guys, they will line up with negative ions, and they'll also, like little cranes, they'll come in and they'll pluck off an ion and they'll carry it away using electrostatic attractions. And this process is what is referred to as dissociation of ions, which in common parlance we may refer to as simply dissolving. Now this diagram is awfully complicated for you to reproduce on an exam, so what I would suggest is drawing a diagram a lot more like this. I start with a water molecule, a slight positive near the hydrogens and a slight negative near the oxygen. And near the positive portion of the water molecule, I will draw a negative ion. I've chosen chloride, and I included 8 electrons since it's a nonmetal ion. I also included brackets and a negative charge. And near the oxygen side of the water molecule, I drew the positive ion, and I used sodium. Since it's a metal ion, I included no electrons, brackets, and a positive charge. So that was a diagram for molecule ion attraction, and the definition for it is going to be the attraction between ions and polar molecules. So in molecule ion attraction, the bonds of the ionic substances break, rather than the bonds of the covalent substance. And the reason that that happens is because after the transfer of electrons, each ion in an ionic bond is stable. That is not true for covalently bonded substances. They need to remain bonded to retain their stability. So when push comes to shove, the ions dissociate from one another rather than the atoms of a covalent substance. So physically speaking, the bond between molecules and ions is not a bond at all. It would simply be an electrostatic attraction. And lastly, I have an intermolecular force that I want you to know called dispersion force. It is the final intermolecular force that I will discuss, and also the weakest. And it occurs as a temporary uneven distribution of the electrons in an atom. It also, and please do write this down, it occurs only in noble gases and other large nonpolar molecules. I will show you this animation tomorrow. You'll see the beginnings of it here. And I've chosen two noble gases, neon. And right now you can see that the electrons are distributed randomly and almost evenly around the nucleus of the atoms. But as these two atoms interact with one another, the electrons will move. I'll draw the after diagram, which I want you to draw, and then I'll discuss. So since electrons repel each other, even electrons between two atoms, as these two atoms approach one another, the electrons will begin to interact. They'll repel. And what that's going to cause is it's going to cause the electrons on this atom to shift all to one side to try to get as far away from the electrons on this atom. And when that happens, it creates a negative pole for this neon atom. And on the other side of that negative pole would be a positive pole. That's because the nucleus, being positive, is exposed on this side of the atom. So now you've got a negative pole and a positive pole, and it's going to cause changes in this atom. The positive pole will cause the electrons in this atom to rush to one side, creating another negative pole, and also, in the wake of that event, causing a positive pole on the other side of that atom. This would continue throughout the entire substance, and overall, you're going to find that these two atoms are more attracted to each other than they would have been when they were in this state, because you have this positive-negative attraction. And it gives these large nonpolar molecules and noble gases an interestingly high, although not objectively high, but a comparatively high melting point and boiling point. So this does have some more dramatic effects, the dispersion forces. I always like to think about geckos, those lizards that can walk up walls and glass and other completely smooth surfaces, even though they don't have claws. You can see from a detailed photograph of their, I suppose, paws, hands, I'm not sure, that they have interesting little pads and ribbed structures. These are filled with large nonpolar molecules that experience dispersion forces. And when they press these little pads to another substance, the dispersion forces will cause attractions between the nonpolar molecules and the substance that it's touching, giving it just enough force of attraction that it can defy gravity and walk up smooth surfaces. And so finally we have reached the pair up. Some of the formatting's a bit strange. This should be a subscript, this should be a subscript. But I do want you to identify the intermolecular forces present in each substance next time I see you. So copy down this bare bones and don't answer yet. And then also please copy down these summary questions. Again, some formatting issues, but I know you'll correct that when we answer the questions tomorrow. Thanks for watching.